Hi everyone. I'm going to continue on this topic, maximum, minimum, and point of inflection. I added this picture just to show you these things with just the graph. So here we have this graph. So the graph is 3 degree. So just 3 degree equation or function. So x cubed minus 3x squared minus 9x plus 1. And I can see I have one maximum point and one minimum point. So if I want to explain what does maximum point and minimum point means, so here you can see maximum, this here means the point which is more than all the point are surrounding it. So just this is more than all the points, just very close to it. So it doesn't mean it's more than all the points in the whole function, because look at this. The function here goes up. So if you increase x, so it will be increased. So I cannot say this is the maximum point for the whole function. No, this is just maximum for surroundings, for the points close to it. Okay, so that's why we call it local maximum. Okay, so how about local minimum? The same. So here, look at this. If I continue, this goes down. So if I reduce x, so I go to x towards minus infinity. So the function also decreases. But this point is not minimum of the function, but it's just local minimum, because it's locally, or just for surrounding points, this is less than all of them. Okay, so we can see this. And then I can just ask you, at what point, 2 points, a slope of the tangent line. Okay, so a slope of tangent line is 0. Okay, so you would say, okay, so a slope of tangent line is, let me change the color. Okay, see, okay, see, for example, for this point, this is a slope of tangent line. For example, for this point, okay, so that's a slope, that's tangent line, and the slope of tangent line is something positive. So for this point, a slope of tangent line is negative, and for this part I can see this is tangent line, and for this part I can see this is tangent line. I know if a line is parallel to x-axis, a slope of that line is 0. So a slope of this line, is 0, and a slope of this line is also 0. Okay, these two lines. And I know tangent line, a slope of tangent line is the first derivative. So I can say for these 2 points, the first derivative is just 0. So this is what I can use in order to find my maximum and minimum. Okay, so when I look at my graph, I see I have one maximum, local maximum, one local minimum. And when I consider tangent line at these points, I can see this is tangent line, this is tangent line here. So these and these here, and both of them are parallel to x-axis, means both of them have a slope equal 0. So that's a very good point to use, because maybe I can say, okay, so for local maximum and local minimum, a slope of tangent line at that point and those points is 0. So means the first derivative at those points is 0. Okay, so I can check that. So here I can say, okay, so yes, these are 0. So how can I say so for these points? So I can say for these 2 points, okay, the first derivative at these points are 0. Okay, because the first derivative is a slope of tangent line, and I could see tangent line is parallel to x-axis. So where is the slope greater than 0? So I look at here and I see, for example, here the slope is greater than 0. Okay, how do I know? Because I know when a line is going up, the slope is positive. Okay, a slope is positive here for this. So here a slope is positive. Okay, and here a slope is negative. Okay, for these two lines. And when slope is positive for tangent line means y prime, the first derivative is positive. And here the first derivative is negative. Okay, I can see this. Okay, so what do I notice here? I notice the function is increasing. Okay, so the function is going up, and here the function is coming down, so it's decreasing, means y values are going to be larger and larger and larger. So y values start from -20 and then it goes to -10 and then it goes to 0, so it's increasing. And here the y values are decreasing. So from here, from this point, y values it boots coming down. So you can see it starts from, what is that point? So it goes 2 by 2. Yes, from 6 it comes to -26, I think. Okay, so yes, here -26. So it's decreasing. Okay, so I can say, okay, so stop is positive. Okay, so I can say stop is positive if the function is increasing, and I show increasing this way. Slope is negative if the function is decreasing, and I show decreasing this way. Okay, so by just looking at these things, mathematicians they just made this fact that they can define critical points. Okay, and then they can connect or link those critical points to maximum and minimum. Okay, so they just made a definition. So uh, critical points are those points that the first derivative is 0. But I can say the definition is not completed. The definition, based on mathematics, the definition is just something is missing. Critical points are those points that the first derivative is 0 or the first derivative doesn't exist. So the first derivative does not exist. But you don't see this part in the college. If you go to university, you see this. Okay, that's why we don't include it in the definition. But in reality, I should include it because it's definition of critical points, and definition is something that I accept and I cannot change it. Okay, so definition again for critical points are those points that the first derivative is 0 at those points and the first derivative doesn't exist. But you don't see this in the college. Okay, so we don't include it. Okay, so if I tell you I want you to find critical points for me, you have to do first derivative, put first derivative equals 0 and find those points that make first derivative equal 0. And then you are done. You can give me critical points. But make sure to find y as well, because if you find x, that's not enough. You have to find y as well. Look at this. If I just say my point here is x equal -1, here if I say x equal -1, it's not my point. No, my point is this one. My point is this: x equal -1 and y equal 6. This is my point. So the red point. So I have to mention x and y. Okay? So here, increasing and decreasing. Okay, can I say this? Yes. When I look at my function, I see when y prime is positive, a slope of tangent line is positive, so I can see the line is going up, so I can see the function is increasing, like here, and it's increasing like here. Okay, but when I see a slope of tangent line is negative, I can see it's decreasing like this. Okay, coming down. Okay, so I can use this as well and say increasing, decreasing. If the first derivative is positive, it's increasing from somewhere to somewhere, so it's maybe at one point or just from somewhere to somewhere, so it's an interval. It's an interval. So if it's negative, it's decreasing. Okay, so in order to find decreasing and increasing, I have to see where y prime is positive or negative. So first I have to find where y prime is 0. Okay, so remember, positive increasing and negative decreasing, and I show it this way. Okay, so now I go here, find critical points for this function. I told you critical points are where the first derivative is 0. So you have to do for this, you have to do first y prime, it's 3x squared minus 3. Yes, and then you have to do 2 y prime equals 0. Yes, you do 3x squared minus 3 equals 0. So you have 3 times x squared minus 1 equals 0. So x squared equal 1 and x is plus minus 1. Don't forget you have two answers, not just one, plus minus 1. Okay, so you have 2 points. But I cannot say this is my critical point because I have to find y as well. Okay, so I put x equal 1 and I find y. So 1 cubed minus 3 multiple 1, which is minus 2. I put x equal minus 1 and then I find y. Minus 1 cubed minus 3 times minus 1, which is 3 minus 1, which is 2. Okay, so I can say I have two critical points. I can write it this way, critical points, and even in the exam, so you can write this way, and I accept two critical points. One of them is 1 and minus 2, and one of them is minus 1 and 2. Okay, these are my two critical points. So then it's asking, is the function increasing or decreasing in this and this and this? So means I have to check if the function, if the first derivative is positive or negative here. Okay, where is first derivative? Okay, so first derivative is 3x squared minus 3. Okay, then I continue. Okay, y prime at minus 2 is what? Okay, y prime at minus 2 is 3 minus 2 squared minus 3, which is 3 times 4, 12 minus 9, 3 is 9, is positive. So at this point is increasing. Okay, or I change the color maybe to link them together. So I do this. Okay, so increasing. So if you do it with just this arrow, or if you write increasing, I accept. Okay, so for the other one, y prime at 0. Y prime at 0 is minus 3. Okay, which is negative. So it's decreasing. Okay, it's decreasing. So I can link them this way. Yeah. And how about at 2? So again, if y prime at 2, y prime at 2 is the same as that one, which is 9, and that's positive, so it's again increasing. So here is again increasing. Okay, and you can look at the function. The function is here. Okay, look at this. I found two critical points. One of them is 1 and minus 2. This is 1 and minus 2. This one is minus 1 and 2. I can see this is maximum. I can see this is minimum. I can see at 0 is decreasing. Look at this. At 0 is decreasing. It's going down. It's going down. And 2 and minus 2. So at minus 2, which is here, is increasing. And at 2, which is here, it's increasing as well. Okay, so the graph also shows me, right? So now I continue here to this question. The rate of a chemical reaction is described by this equation. So I don't even maybe consider the chemistry part or the physics part, for we are doing just with math. Okay, but you can also, you can also understand that from that perspective. So here I just do care about like the function and what is in terms of math. Okay, so it's the rate of a chemical reaction is described with this. So C is concentration, milligram per milliliter, and at t second. So we are just considering concentration at different time. Okay, so okay, in seconds. So is the rate increasing or decreasing when this and this? Remember, if I say increasing, I have to check y prime first. I have to find y prime, and I have to see if y prime is positive. Decreasing, I have to see if y prime is negative. Okay, so I do it step by step. Okay, I find c prime. Why? Because I'm asking about increasing, decreasing. So I don't have anything to do with the whole function. I have to find derivative, first derivative. Okay, first derivative is 0.2 minus 0.8 t. So what is c prime at 2? Okay, c prime at 2 is 0.2 minus 0.8 times 2, which is 0.2 minus 1.6, which is negative. What is c prime at 4? C prime at 4 is this, so it's this times 4. It's even more negative. So 0.2 minus 3.2, okay, which is negative. So at these 2 points, it is decreasing, because both of them are, at these 2 points, the c prime is negative. I don't know what is wrong here. Yeah, that's just crazy thing. Okay, so, okay, look at the function here. Look at the function, look at 2 and 4. Okay, so look at 2, this is here. Look at 4, this is here. And both of them, you see it's decreasing. Okay, both of them is decreasing. Of course, I shouldn't mention this part. This was just, I asked the graph, and so for them, it doesn't matter. But here, because t is positive, so it's just that part. Okay, so from 0 to more, sorry, the time is increasing, so from 0 to more numbers. Okay, so positive numbers. So here I want to mention some points. We told you if the first derivative is 0, okay, so we believe this. We look at maximum minimum and we say, okay, first derivative is 0 at these 2 points. Okay, so yes, we accept. If we have maximum minimum, the first derivative is 0 at those points, at maximum and minimum. But it doesn't mean, this wasn't part of the lesson, but many things were missing. So I just wanted to add these for, not missing. So I mean, just to, that I want you to understand better. If you in future you go to university, you will see this in calculus. So it's good that you know. It doesn't mean if the first derivative is 0, for sure I have maximum minimum. No. See, if I have maximum minimum, if I have minimum, for sure the first derivative is 0 at those points. And I saw it in the graph. Okay? But it doesn't mean if the first derivative is 0, for sure I have maximum minimum. No, maybe I don't. Why? Look at the function. The function here is y equal x cubed. What is first derivative? 3x squared. Okay? So y prime at 0 is 0. Okay, at 0 is 0, yes. But when I look at here, I don't see maximum minimum. I just see it's going up. Okay? So, again, if I have maximum minimum, yes, I do have first derivative equals 0. But it doesn't mean if I have first derivative equals 0, I for sure have maximum minimum. No, this is the example. Y equal x cube. I don't see any maximum minimum, but the first derivative is 0 at 0. Okay, so then how can I make sure that I have maximum minimum? Okay, method to find maximum minimum. First, find first derivative. Put first derivative equals 0 and solve for x, means find those values. Okay, substitute those x and find y values. I told you have to find y as well. Okay, these points are critical points. Okay, but I told you if you have the first derivative equals 0, it doesn't mean for sure you have maximum minimum. Why? Because look at this. I saw it. Okay. So how can I say I have maximum minimum? For sure. Okay. See, I find the first derivative and I put it equal 0 and I look at here. Here the first derivative is 0. Before this point, the first derivative is positive because it's increasing. After is decreasing. So the first derivative must change the sign from minus to plus or from plus to minus. Look at here. Here it changes from plus to minus, means increasing, decreasing. And here is decreasing, minus to plus. In that case, I can say for sure I have maximum minimum. So, in order to say maximum minimum, look at this. Here I don't, because it's positive, because it's increasing, and positive, it's increasing. So it's not changing from minus to plus. So I have to find the first derivative, put first derivative equals 0, find the points, you find y values. These are for sure your critical points, but it doesn't mean they are maximum minimum. If you check and you see y prime changes from positive to negative or from negative to positive, you see here you have minimum and here you have maximum. This is maybe hard, so I can show you something easy, which is second derivative method. Okay, this is second derivative test. We call it second derivative first test. Sorry. See, you find the second derivative. If second derivative at that point is positive, for sure you have minimum. If second derivative at that point is negative, for sure you have maximum. So again, if the first derivative is 0 at a point, it doesn't mean for sure I have maximum minimum. No, I should check this test, or I should check this. But this is easier, okay, and faster. Now I can do it here. Determine the critical points of this function and check if they are maximum minimum. Step by step. If you follow this, so you are going to be fine. So y prime, and the lesson is not hard, but you have to just do several steps. So you have to do certain steps here. Okay, y prime is what? 3x squared minus 6x. Okay, the next step. Y prime equals 0. 3x squared minus 6x equals 0. So 3x times x minus 2 equals 0. Okay, so x is 0 because of this, and x is 2 because of this. Okay, so I better change the color because I can link this to this one. Okay, so but I told you, you have to find y as well. If x equals 0, y is minus 2. If x equals 2, y is 8 plus 3 times 4, 12, 20 minus 12, 2 is 18. I'm not sure. Let me see if I have the 2 at 2. Okay, so I can find with my calculator. The problem is I don't have the. Okay, so 8 plus 3 times 4 minus 2. Yes, 18. Okay. Oh, the problem is I made a mistake here. That's the issue. I'm thinking. Yes, I'm thinking here. Okay, plus, sorry. Plus and plus and plus and minus 2. Okay, so when I do minus 2, I'm thinking it doesn't make any sense for the graph when I look at graph. So minus 2 is minus 8 plus 12 minus 2, which is 12 minus 2 minus 10, which is 2. Okay, minus 2 and 2. Perfect. Minus 2 and 2 here. Minus 2 and 2 is here. And 0 and minus 2 is here. Okay. So I have 1 point, minus 2 and 2. I have 1 point, 0 and minus 2. Okay. Let me show you the first method, and then I do the second method. The first method, I told you, if I want to say maximum minimum, I have to find the first derivative. Sorry, if the first derivative is positive or negative. Okay, so I do this. Where is first derivative? This. 3x squared plus 6x. Where is first derivative? 0. 0 and minus 2 and 0. So I write minus 2 first and 0 next. Okay, 0. Okay, the first derivative is 0 at this point and at this point. Before, between, and after these points, the first derivative is either positive or negative. Of course, there is no other choice. There is no other options. 0, positive or negative. Okay, the first derivative. I can check a point here. I can check a point here, for example, minus 3, for example. I can check. Here I can check a point minus 1, and here I can check a point 1. Okay? And I can see. If I put minus 3 inside, if I put minus 3 here, I can see 3 multiple 9 minus 18 is positive. Okay? And I can see it is increasing. If I put minus 1, I can see 3 plus minus 6 is negative, so it's going down and it's going up. Okay? So I can see it's going up and coming down, it's coming down and going up. So I have maximum and I have minimum. Also, I can say from minus infinity to minus 2 is increasing. From 0 to infinity is increasing as well because it's going down, it's going up. From minus 2 to 0 is decreasing. And I can look at the graph and see. Okay? Decreasing. And here I can see increasing. Okay? This is a little bit harder. So I recommend you to use second derivative method. Second derivative is, you can check the second derivative. What is second derivative? Second derivative is 6x plus 6. 6x plus 6. Okay, so yes, let me write it neatly. Okay, second derivative, second derivative at which point? At minus 2. Second derivative of minus 2 is minus 12 minus 6. Minus 12 plus 6. Am I right? Yeah, plus 6, which is negative. I told you, if second derivative is negative, you have maximum. Oh, easy. If second derivative is positive, which is at 0, it's 6. That's positive, so I have minimum. Okay? So, remember, you find first derivative, put first derivative equal 0. Okay? Find those points. Find y related to those points or correspondence to those points. Then, if you do this way, you can see first derivative is 0 as those points, before, between, after. I can check a point. I can check a point before minus 2, between 0 and minus 2, and after 0. And I can see the first derivative is positive, negative, here negative, and here positive. So it's going up, coming down, going up. So this means maximum, minimum. This is time consuming, but it shows you increasing, decreasing as well. But if you use second derivative test, it's easier and very fast. Second derivative, if second derivative is negative, you have maximum. If second derivative is positive, you have minimum. Okay? So I stop the video here because if I want to stop to talk about this, it will be longer. So then I have to go. So I don't want to stop at just in the middle. Okay? So I continue after. Thank you. Okay, so here I can write today is 22 and this. Okay, thank you so much.